Hello, and welcome to the Math 0362 Test 5 review. I hope Test 4 went okay for everyone. Like I said in the previous broadcast, Test 4 was probably the easiest test of the year. So I hope everybody was able to take advantage and enjoy a little bit of a bump in your grade. Unfortunately, we're going to need that grade bump because Test 5 is the most difficult. So, as a result, instead of doing everything at once, I'm going to divide Test 5 into 4 parts. Part 1 is question 1 through 9, and that's where we start. Question 1. They'd like us to solve the radical. Well, before we can solve the radical, we're going to have to add 6. So square root of y plus 5 equals to 6. Now, in order to get rid of the square root radical, you can just raise to a power 2. It's okay as long as you do it to both sides. So as a result, you're left with y plus 5 equals 36. Then subtract 5. And what's left is y equals 31. And that's your answer. 2. You notice how I wrote 2 in red. I did that intentionally because this is a trick question, and I will show you why. Let's say you didn't know it's a trick question because they're not going to use red ink on the test. First step will be to subtract 9. So as your result, you get 4m plus 5 equals to negative 5. This is where the problem occurs because square roots are never negative. And I'll even write that out. Square roots are never equal to negative numbers. So, no solution. Question 3. I'd like to solve, and the way to solve is to raise both sides to a power 2. And what that does is it releases 6k plus 19. Now, unfortunately, with k plus 2 squared, the square means write the problem twice in FOIL. So, k times k is k2. K times 2 is plus 2k. 2 times k is positive 2k again. And 2 times 2 is 4. Well, notice that 2k and 2k are able to add up to become 4k. Not a problem. k2 plus 4k plus 4 still equal to 6k plus 19. At this point, you may notice there's a power 2, as in k2. In order to solve anything with a power 2, everybody has to be on the same side. So this means we're going to have to do minus 6k and minus 19. So as a result, you're left with k2 minus 2k minus 15. This will factor. k2 becomes k and k. And two numbers that make 15 that I like is 5 and 3. In fact, I like negative 5 and positive 3. Why? Because negative 5 plus 3 equals negative 2, the middle number. We can now treat this as two separate problems. So k minus 5 equals 0, means k equals to 5. And k plus 3 equals 0 means k equals negative 3. Now we have to check our answers just to make sure. So let's start with 5. If you do 5, that means 5 plus 2 is equal to the square root of 6 times 5 plus 19. 5 and 2 is 7. 6 times 5 is 30, plus 19 is 49. And yes, the square root of 49 is 7. So 5 is good. Let's try negative 3. So you get negative 3 plus 2 equals to 6 times negative 3 plus 19. Well, wait a minute. Negative 3 plus 2 is negative 1. And earlier, didn't we say square roots cannot equal to negative? So that means negative 3 is bad. So 5 is the only good answer. Okay, number 4. Solve the radical equation. Again, we're going to raise both sides to a power 2. So I'll do 2 here and 2 here. The n plus 4 squared just means FOIL n plus 4 with itself. Okay? So n times n is n2. N times 4 is 4n. 4 times n is 4n, again. And 4 times 4 is 16. And the 4's can add to become n2 plus 8n plus 16. All right, great. We'll come back to that. Over here, 5 squared is 25. And then the little 2 just means the radical disappears, so it just becomes 25n. Okay, once again, because of n2, everybody has to be on the same side. So this means minus 25n. So you're left with n2 minus 17n plus 16. We're now ready to use double parentheses for factoring. I like n2 because that becomes n and n. Today for 16, I'm going to go with 16 and 1. In fact, I'm going to do negative 16 and negative 1 because that's equal to negative 17. So you may treat it as two problems. Oops. What is, hang on. Get down there. Okay. So n minus 16 equals 0 means n equals to 16. And n minus 1 equals to 0 means n equals 1. So let's check. For 16, that means 16 plus 4 equals to 5 times square root of 16. Square root of 16 is 4. 5 times 4 is 20. 16 plus 4 is 20. So 16 is a good answer. Let's check 1. 1 plus 4 equals 5. 5 times square root of 1 is also 5. You get the same thing. So 1 is also good. So in this case, you get two good answers. Number 5, very easy. Let's ignore the negative for a moment. 90. Two numbers that make 90 are 9 times 10. I like 9 because 9 is perfect. It's 3. But 10 is not perfect. It stays in the house. As for the negative, negative means the letter I. 3i10. Done. Okay. 6 is sometimes a trick question because when students see two parentheses, they think FOIL. This is not FOIL. It's easier than FOIL. Now, how do I know it's not FOIL? Because there's a plus sign in between, that's why. But it's like I said, it's easier than FOIL. First, let's just add the regular numbers. 3 plus 10 is 13. There's your first answer. Next, add the i's. 6i plus 8i, that is 14i. And you're finished. Perform the indicated operation. In order to do this, I would bring in something called the conjugate. And what the conjugate is same numbers but opposite signs. So I'm going to bring in top and bottom 2 minus 5i. The next step is something I call double FOIL. It means I will FOIL the top, then FOIL the bottom. Let's start up top. 6 times 2 is 12. 6 times negative 5 is negative 30i. Okay, great. We'll come back to that. Let's go to the bottom. 2 times 2 is 4. 2 times negative 5 is negative 10i. Negative 5i times 10 is positive 10i. And 5i times negative 5i is negative 25i squared. A couple of things happen. First, negative 10 and positive 10 go away. Next, notice I squared. I squared is negative 1. But if you don't know that, you don't need to know it. What you do need to know that is that I squared will change signs. It changes negative 25 into positive 25. And don't forget about 4. So 4 plus 25 is 29. And that's what goes underneath. All right, 8. Let's just multiply. Negative 2i times 2 is negative 4i. Negative 2i times 11 is negative 22i squared. Now again, I squared will change negative 22 into positive 22. And you still have negative 4i. Now, this is technically correct, but there are a lot of instructors that would rather have the number come first and the I come second. If your instructor is one of those, then write 22 minus 4i. Okay, number 9. This is a FOIL question because the parentheses are right next to each other. So, 10 times negative 10 is negative 100. 10 times 9i is positive 90i. 8i times negative 10 is negative 80i. And 8i plus 9 times 9i, that is positive 72i squared. All right, a couple of things. First, in the middle, 90 minus 80i, that is going to be positive 10i. Next, I squared is going to change positive 72 into negative 72. But don't forget there's a negative 100 waiting. So negative 100 and negative 72 becomes negative 172. And then plus 10i. And that's our answer. So that concludes part 1 of the Math 362 Test 5 review. Please go to our website and tune in for Test 2. And remember, this time there are 4 parts to this. So we'll see each other in a few minutes.